Hello guys and welcome to another episode of Videos and Munch. And my name is Prarit. I'm studying Sri Venkateswara College of Engineering of 6M. So, in the field of CS Computer Science Artificial Intelligence. And today we are going to be talking about data warehousing of the subject from business intelligence. Data warehousing is a critical component of modern business intelligence and analytics. A data warehouse serves as a centralized repository for an organization's structured data, providing a 360-degree view of the business and enabling informed decision making. At its core, a data warehouse consolidates data from various sources, cleanses it, and transforms it and stores it in a format optimized for analysis reporting. So first, the data will be gathered as shown here in the diagram, and it will be cleaned, and the data will be stored in the warehouse, and it can be shared for optimized analysis and reporting. Key components of data warehousing: extraction, transformation, and loading. The ETL process is responsible for extracting data from source systems, transforming it to the fit warehouse, data warehouse schema, and loading it into the data warehouse. This ensures data consistency, completeness, and quality. The ETL transformation is basically extracting data from a source and transforming it, meaning cleaning the data and transforming it to a warehouse schema and loading it into the data warehouse. This ensures data is consistent, quality, and completeness. Data storage. Warehouse utilizes specialized storage technologies such as relational databases or data lake platforms to efficiently store and manage large volumes of structured and unstructured data. Business intelligence tools. BI tools such as reporting, dashboarding, and analytics applications enable users to access, analyze, and derive insights from the data stored in the data warehouse. Data extraction, transformation, and loading ETL process. So in the ETL process, as we know, first one is extraction, second transforming, and the third one is loading. So extraction process begins with the extraction of data from various source systems such as transactional databases, CRM systems, and external data sources. This step ensures that all relevant data is captured and prepared for the next phase, transformation. The extracted data is then transformed to fit the data warehouse schema. This includes data cleansing, normalization, and application of business rules to ensure data consistency and quality. Loading. The transformed data is then loaded into the data warehouse where it is stored in a format optimized for analytical processing. This step ensures the data is readily available for users to access and analyze. So you can see in the diagram over here, we will be extracting the data from various sources or various external data sources or CRM systems, and then it will be transformed where it will be loaded into the analytical warehouse, and then the loading process takes transformation, sorry, that data will be transformed into the analytical warehouse schema, and then it will be analyzed for getting better data. So dimensional modeling and schema design. Star schema. The star schema is widely used dimensional model in data warehousing. Consists of a central fact table that holds numerical measures of interest surrounded by dimension tables that provide context and descriptive information. Snowflake schema. The snowflake schema is a variation of the star schema where dimension tables are further normalized, creating a hierarchical structure. This approach can provide more granular data and improve query performance for certain use cases. Data marts. Data marts are specialized data warehouses that focuses on specific business function or department. They provide a more targeted and tailored view of the data, making it easier for the users to access the information they need. So data marts are like the small parts of data warehouse where it focuses on business function. which helps the users to access the information they need easily instead of searching or going through all of the data warehouse to find what they require. Data warehouse architectures and patterns, Lambda, Kappa, Hybrid, and Polyglot. Polyglot. The Lambda architecture combines batch processing for historical data and real-time processing for streaming data, providing a flexible and scalable solution for handling both types of data. The Kappa architecture simplifies Lambda approach by using single stream processing engine to handle both batch and real-time data, reducing complexity and maintenance overhead. The hybrid architecture combines on-premises data warehousing with cloud-based data processing and storage, allowing organizations to leverage the best of both worlds and optimize their data infrastructure. Polyglot architecture embraces the use of multiple database technologies as relational, NoSQL, and in-memory databases to address the diverse data storage and processing requirements of a data warehouse. On-premise versus cloud-based data. On-premise data warehousing involves hosting the entire data infrastructure, including the software and IT sources, within the organization's own data center. This approach provides more control and customization but requires significant upfront investment and ongoing maintenance. Cloud-based data warehousing. Cloud-based data warehousing leverages the scalability, flexibility, and cost-effectiveness of cloud computing programs such as Amazon Redshift, Google BigQuery, Microsoft Azure Synapse. This model shifts the burden of infrastructure management to the cloud provider, allowing organizations to focus on their core business objectives. Okay, the hybrid approach combines on-premise and cloud-based data warehousing, allowing organizations to leverage the benefits of both models. This approach can be particularly useful for organizations with existing on-premises infrastructure or specialized data and processing requirements. Now let's talk about data warehouse performance optimization, how the performance can be optimized using various techniques. Data partitioning the data warehouse tables based on frequently used columns can significantly improve query performance by reducing the amount of data that needs to be scanned. Indexing. Implementing appropriate indices such as BT, bitmap, and column store indices can accelerate data retrieval and enhance the overall performance of the data warehouse. Materialized views. Materialized views pre-compute and store results of complex queries, reducing the need for real-time computations and improving query response times. Query optimization. Leveraging the data warehouse query optimization engine along with the techniques like querying, rewriting, and workload management can further enhance the performance of analytical queries. Now let's talk about the conclusion. Data warehousing has evolved significantly over the years, and it continues to be a critical component of modern business intelligence and analytics. As organizations generate increasingly large and diverse data sets, the need for scalable and flexible data warehousing solutions has become more essential. Looking ahead, we can expect to see continued advancement in areas such as cloud-based data warehousing, real-time data processing, and integration of the machine learning and artificial intelligence into data warehousing platforms. These emerging trends will enable organizations to extract even greater insights from their data and make more informed data-driven decisions. Thank you, guys, and if you have found anything useful by watching this